Hello students, today I'm going to go through our lesson for 5-6, Properties of Logarithms. And I saved this lesson in a Kami document on your Google Classroom, so you can open it up and you can write right on it with your stylus. And then if that doesn't work for you, you can take notes on paper, and I'll just point out some of the really important properties of logarithms that we're going to learn today. We're not going to do all the notes. We're just going to do some of the most important examples that'll get you ready to be working on your formative. So the first thing I'm going to do is skip over our Explore and Reason and come right down to the bottom of the first page where we see the concept properties of logarithms. And this box is going to be really important, and it's also repeated at the very end of our lesson. But these are 3 properties we're going to talk about today. And the first one is it's called the product property of logarithms. And in log world, just like in exponent world, multiplication is related to addition. And so in the first property, we're going to see that the log base b of m times n, if you have multiply, that is going to expand into log base b of m plus log base b of n. And so multiplication and addition are kind of buddies in log world. Now, our second property that we're going to see is a division property. They call it the quotient property of logarithms. And if log base b of m divided by n is a quotient, we can separate that into 2 separate logs using subtraction. So we get log base b of m minus log base b of n. And finally, the third property we're going to get today is called the power property of logarithms. And this property says that if you have a power of m, we can actually move that right to the front of the log and it becomes a product. So that's how we'll be able to get some of our powers down in front, and that'll help us to solve some of our log equations. So this box is going to be really important. You can go back to it, and then there's another one at the end. So now I'm going to go past example 1. We're not going to prove the properties today, but what we're going to do instead is kind of practice them. So in example 2, we are going to be expanding the logarithms, expanding these expressions using the properties that we just learned. So we want to use the properties to expand each expression. So right now we have 1 log, and when we have 1 log and it says expand, that means we're going to turn it into a couple of expressions. And so we have to look and see what's been done to it. So first of all, I see log base 5, and then I have a squared times b to the 7th. So the first thing I'm going to do with this expression is separate the multiplication into addition. And I'll get 2 expressions, log base 5 of a squared plus log base 5 of b to the 7th. So multiplication expands into addition. The second thing that happens is that we have these powers, and the power property says those powers can go in front. And so for our final answer, we'll have 2 log base 5 of a plus 7 log base 5 of b. And that's a fully expanded expression. Now, in part B, we see a natural log, and remember, any properties that apply to logs will always apply to natural logs as well. So I do see a quotient here, so I can start by separating this into 2 log expressions, natural log of 25 minus natural log of 3. And that's all we have to do with that one. There are no powers. Okay, let's pick one more to try. We'll do part A in the try it number 2. We can see there's a few things going on with this one. We do have a quotient, so we're going to do that part first, and then we'll see what else we need to do. So log base 7, and then our first expression is the top, and that's going to be our r cubed t to the 4th, and then we're going to have minus log base 7 of v. That takes care of the quotient, but maybe you notice we also have a multiply in here with the r cubed and the t to the 4th. So those get separated as well. So now we'll have log base 7 r to the 3rd plus log base 7 t to the 4th minus log base 7 of v. And then there really is just one more thing left to do. Maybe you notice that both of these have powers. Remember that those powers go in front of their logs. So we're going to move those to the front as a product. And final answer, 3 log base 7 of r plus 4 log base 7 of t minus log base 7 of v. Okay, so that kind of wraps up our example 2. On the next page, we're going to go backwards, and we're going to take these expressions and we're going to rewrite them as a single log. So it might help us to get this down into 1 log expression, and we'll see later that's going to help us solve some equations. Okay, so we do the steps in the exact reverse order. So the first thing I'm going to look for is any products here. Like we see a 4 times the log, and we see a 3 times the log. So the first thing we're going to want to do is bring those up. So those come up. Log base 4 of m to the 4th plus log base 4 of n cubed. And then this one's minus log base 4 of p. After that, we want to try to get this down into 1 log. So I notice 2 operations. Notice first I have addition, then I have subtraction. So we'll start with the addition and we'll pull those 2 together. So we can rewrite this as 1 log expression, log base 4, m to the 4th times n to the 3rd, but we still have minus log base 4 of p. Okay, now that we have a division, we can finally get this down to 1 log expression by condensing down to 1 log base 4. And remember that division, it goes with subtraction, so we'll have m to the 4th n cubed divided by that p. And that becomes our final condensed log expression. So we got it down to 1 log. So there's kind of a lot going on in that problem. The b part is a little bit simpler. In the b part, we're going to do the same first step. We're going to bring up our 3. We're going to bring up our 2. Remember, those are powers. So natural log of 2 cubed minus natural log of 5 squared, which we can simplify. Natural log of 8 minus natural log of 25. Now, to get it down to 1 natural log, all we need to do is use division. So natural log of 8 divided by 25. And that's our final expression. And so that's how we condense. So again, we'll do just 1 more of those to make sure you've got it. If you've already got it, you can move on. But we'll do 1 more. Maybe you want to pause here and try 3a by yourself. You can do that. So I see some powers. They're going to go up to the top. Log base 2, c to the 5th, minus log base 2, n to the 7th. Okay, and we just want to get it down to a single logarithm. That's our direction. And now we can rewrite as log base 2, and subtraction becomes a division problem. So log base 2, c to the 5th over n to the 7th. And that's our final answer. The last little thing we're going to do here is something we kind of already talked about in class for those of you with calculators that do not allow you to put a base in. And this is something that's called the change of base formula. So I'm going to scroll ahead a little bit in here, go past some of these, and we're going to talk about this change of base formula a little bit. So in example 5, you're going to see a question. How can you use base 10 logarithms to evaluate a base 2 logarithm, or really any base logarithm? So let's say you want to solve log base 2 of 3. Many of your calculators allow you to already type that in, and if you can do that, great, go ahead and do that. But if you can't, there is a change of base formula that will allow us to solve that, and it's right down here at the bottom of the example. They kind of make it a little harder in here, so I'm just going to point to you right down here where it says log base b of m. All you have to do is put into your calculator log of m over log of b. And that little a, well, that's just base 10. So really, all you have to do is put in log m over log b. And that base is just 10. So I'll show you how to do that. If you have your calculator handy, go ahead and grab it. If not, you can just watch. So, like I said, some calculators you can type in that little base 2, and you can just type in log base 2 of 7. Others you can't. So, if you want to do this with base 10 logs, you just have to do log 7 divided by log 2. And anyone can type that into their calculator because everyone has log on their calculator. So that's about 2.807. Or in this one, we want to do log 3 over log 5. And again, just remember that the base goes on the bottom. Keep the b's together. The log base 2 went on the bottom, the log base 5 went on the bottom, 0.683. So I think that's enough notes for us to do for right now. And we can, clean it up when we're back in school, hopefully tomorrow. So now I'm going to have you go ahead to your, you can go to your formative and start working on some of those problems. Have a great rest of your day.